Hello, everyone. Thanks for tuning in to our After Dinner Min series titled Behind the Code. On the show, we welcome art blocks artists to share a deeper look into their project's creative coding and process. Today, we welcome DCA, Daniel Calderon-Arenas, who joins us to speak about his Plottables project, Really Random Rock. At the end of the show, we'll open the floor to questions that have been asked on the live YouTube page or Discord. I'll let you take it from here, Dan.
Thank you. I just want to start off with saying thanks for having me. It's an absolute pleasure to be here. Very rarely do I actually get to talk about my code, and this is an opportunity to do just that. So thanks for having me. All right. Well, I'm going to jump right into the project here. So what you see on the screen right now is a demo script, which basically just shows the process of how these rocks are made. The original Really Random Rocks script is a different file, but it's also really long and a little bit disorganized compared to this. So let me run this for you so you can kind of see the process. Just gonna let that run here, and you can watch what's happening. And then in a minute here, I'll explain that in further detail. Basically, a rock is getting generated here. Basically, this is the overall process. And what I want to do is kind of dive in and break this down step by step and explain exactly what is going on. Let me just let this finish here. It's almost done. It's just shading in all these areas. And then I'll break it down. Okay, so looking at the code, I'm going to be jumping back and forth from this sort of code view to this rock view. And I'm doing that because I need to make changes in the code that will reflect in the sketch. So here's the very first step. Okay, the first step is draw a line, wait for it to intersect itself, and when it intersects itself, stop. So here's basically every time I refresh, it's creating a new line and seeking itself. I mean, this line could go on forever in any direction, but the minute it intersects itself, it stops, right? And notice when it intersects, you have this sort of shape right here, and then this tail. There's a long tail, right? So what I'm going to do is clip off this tail, grab this shape, and then center it and scale it up to fit the screen. So let's see that in action here. So there it is. It intersected, it scales up, and it fits the screen. And then what I'm left with at this point is a rock that is composed of a whole bunch of points that are just, sequential points that form a line. And in this view, you can kind of see all the points. So here's point number 0, and it just increases sequentially around the rock. So the next step is actually, it's kind of like a game. Pick a random point on this rock. Let's say like point number 52. And draw a line outwards from this point. And there's only 3 possible things that can happen. So the line could go on forever and never really do anything. If it does that, I throw it away and I start over. Case number 2 is the line could go out like this and it could self-intersect again. If that happens, I throw it away and I start over. Third case is the line grows and then it sort of travels in a direction where it intersects the original shape. That's the condition I'm looking for in this step. So If that happens, then I keep that line and I splice it into the shape. So in this view, you can kind of see that happening. Let me take this off real quick. There you go. So there's one line going out. It intersected. When it intersects, it splices into the shape. If it takes too long, I just throw it away and try a new line. If it self-intersects, I throw it away and I try a new line. If it reaches all the way to the point where it intersects with the main shape, then I keep that line and I splice it into the original shape. So what's happening here is basically like a random shape is being grown. It's being grown by all these random lines that are, maybe they intersect, maybe they don't. But when they do, it adds dimension to that rock. It adds like volume to the rock. So that's how I'm getting these like very unusual shapes that are, they're kind of organic, but at the same time they're a little jagged. This next step is one of my favorite steps. So once I have that shape grown, let's let this one grow here. The next step is actually really interesting. And it involves taking this shape that has now many dimensions to it and finding a position to display it in. So I'm looking for like if you can see down here, this green line is intersecting the shape, and I'm looking for points where there's a lot of intersection points. So like occasionally you'll see like 4 dots pop up, or 6 or 8. And the reason is because I want to position the rock in an orientation that is not sitting like on a very fine point, like it's balancing or something like that. So let's see that in action. I'm going to just simplify this a little bit and speed it up. So here we go. Now I'll explain here in a second how this is all happening in the code. Really what I want to do is just run through the algorithm in a visual sense, and then I'll talk more about the code. Okay, so there it is, calculating all those points on the bottom. And then it rotates the rock to the most favorable position. So if I open up my console here, I can see all of that data about the points intersecting down below is just collected into this array. And so I can see here that at 348 degrees of rotation, there was 6 intersection points. At 96 degrees of rotation, there was 4. At 189 degrees, there was 4. Right? So I'm looking for the value with the highest intersection points, and then I'm rotating it by that amount. This next step here is it's mostly just for plotting purposes. What I'm doing is I'm adding a second outline to the rock. So after the rotation happens and it finds its configuration, I basically add a second outline. It makes it thicker, and then whenever it gets plotted, because remember this work is all for plotting, it makes it just a little bolder, and it looks much nicer. Okay, so this next step here, we got to run through this every time, so gotta let the rock form before it gets to the next step. So here we go. So this next step is the drop shadow, and you can kind of see that happening. So what I'm doing for the drop shadow is I'm taking this shape as a whole, and then I'm scaling it down on the y-axis. A given amount. I think this is 25% of the height. So that's basically how I'm getting the drop shadow. Depending on the rock, the drop shadow could be really intricate, or it could be really simple. Oh, here's an interesting one. But in this case, you can kind of see what's happening here is the hatching. So that's the next step. And I'm going to slow this down so you can see it in more detail. I call it hatching. You might call it shading. I don't know, whatever words are out there, but I call it hatching. Basically what I'm doing is I'm drawing a whole bunch of lines and then clipping out the lines in the areas where they shouldn't be. So this is just a slow motion version of it. So it draws the lines and then it clips out the, there's exclusionary areas like the inside of this rock. I don't want any lines in there, so I clip them out. So at this point, we have a nice rock shape. It's got the grid behind it. It's got a drop shadow. So these next couple of steps are adding the texture. So let's see here. I forgot to do this no loop here. Do that one more time. So on this next step, what I'm going to do is walk around the line of the outline of the shape. And I'm looking for places where there's a very sharp angle. So I'm basically counting the degrees of angle change between each line segment. And if there's a high degree of change, I capture that point. Let me run that again and see if we can get more than one point on another try. Okay, so here's another example. So these 2 points here, and you can kind of tell already that in this step, I've added leader lines. So these tiny lines are just leader lines, and they're calculating the direction that this line was traveling in, and then what they're going to do is they're going to extend it. So in this case, what I'm doing here is I'm basically taking both the directions of like, let's say you have this red point. You can have a line coming in from that direction, or you can have a line coming in from this direction. So I'm taking both of those values and I'm picking one. It's like pick one, right? So it's randomly chosen. Is it going to go in this way or is it going to go that way? So you can kind of see those leader lines are there. And in this very next step is where the actual lines are drawn in. And I call them fissure lines. I mean, maybe they're more like crags or something like that. But this little line right there, that's all it is. In a more complex rock, there might be 20 or 30 of them, right? But in this simple case here, there's just maybe 1 or 2. So there's a fissure line. And the fissure lines give the rock a little bit more character. They just make it feel more like intentional, more like an artist would do if they were drawing it in real life. So in this next step, I travel around the rock and I drop in random points. If the random point lands outside the rock, I throw it away. If it lands inside the rock, I keep it. So let's say, like, for example, I'm traveling along this rock in this direction. At each point, I'm calculating the direction of this line segment and finding its normal. So the normal is the line perpendicular to that line segment. So I'm finding its normal. And then from that normal, I pick a random distance to drop a dot into, and I pick a random rotation to drop a dot into. And so what that does is it creates a sort of, just a general shading look to the rock. And there's little things happening here. So for example, excuse me, if the line is pointing in this, to the right, then the distance of the normal that the point gets dropped in is really large, right? And as it travels around down here to the bottom, the line starts pointing more left-like, right? As it travels more to the left, the distance between the normal is very small. And so that creates a sort of a tighter shadow around the bottom, but like a broader shadow around the top. Let me run that one more time just to see another example of that. See if we can get a nice rock shape. There you go. So there's sort of the shading happening. And then in the last step here, I'm just continuing the shading onto the fissure lines, because originally the shading was just on the outlines. So now you can kind of see that these sort of fissure lines are capturing more definition. So in this case, this rock has maybe one example of these little nubs that grow on it. But the cool thing about this algorithm is that you can kind of change it. I can set it to, like, for example, 6. And the more, I call them expansion lines. The more the quantity of expansion lines, the more interesting the rock shape, or the more complex it is. And then also it adds more of those fissure lines, which adds more, character to the rock. So in a nutshell, that's really what's happening with this algorithm. And I want to maybe so pause for a moment and jump into looking at some pictures of this process along the way. Just real quick, this is the original really random rock algorithm. So if I refresh that one, it'll put out a new, like, test mint. But the difference between the algorithm on the blockchain is that everything we just saw, that whole process of building the rock, happens basically in one go. It happens in one go behind the scenes really fast. So it's not animated, and if it was animated, it might take a very long time to actually to generate these things. But because it's happening all in one function, basically, it's able to do it much faster. So looking at some outputs along the way, so this is kind of earlier on. You can kind of, by modifying those expansion lines that emanate from the outside of the rock, I can make them rounder, I can make them jagged, etc. You get different rock results. You get results that are bubbly or jagged or very linear. But just exploring the algorithm over the course of months, I think I started working on this in November 2021, and then I was done with it in beginning of February 2022, and just like so many different directions that it could have gone in. For example, in this case here, this is a rock with tons of expansions on it, and the shading here is just very excessive, I guess you could say. Now this is really nice looking, but it couldn't be plotted. So like designing this whole algorithm, I'm thinking about the plotter and keeping things like that in consideration. There's limits to to what you can do with a plotter. Here's a nice example. This one kind of flattens things out a lot. Feels very graphic, like a screen print. Here's another version. I'm exploring various different ways of sort of shading these rocks in the process. This one feels very like graphite on paper sort of approach. Here's another one. This one kind of looks like it could be glowing around the edges. At one point, I even created like an applet, like a little, like the whole project is like interactive, and you can take this rock and you can sink it into a bed of sand, and you can rotate it and try different configurations of it in the sandbox. That was fun. Here's a random like glitchy things that happen along the way. And then this here, I just love this because it's just two colors, right? Black and white. And this outline is like, it's so specific and so unique. And it's completely random, I think when I got to this point in the code, I thought, oh, wow, this is going to be really interesting. So, and then I have here a really random rock number 154, which is one of the expansion lines actually grew too long. It looped around the entire rock, and then when it intersected with the rock on the other end, it flipped the rock inside out. So, like, basically, if you imagine that this area here is the original rock, and then one of these expansion lines just like grew way too long, and then it did some weird thing where it inverted itself, and it still pushed through. It still shaded itself. It's like it's the algorithm seems to be really resilient, and it can accommodate all kinds of strange glitches and stuff. Okay, so with that said, I want to take a second here, and I want to show you how this sort of algorithm actually can inform like a traditional art practice. So what I'm going to do is just kind of, I'm going to have this sheet of paper here, and I'm going to just basically perform the algorithm in the same way, just with pencil and paper. So, for example, I'm going to just take a line and draw a random line on this sheet of paper. I'm going to pick a random point on this shape and draw a random line. I'm going to pick another random point on that shape, and oh, that one's self-intersected, so I'll just throw that away. Pick another random point on this object and just kind of draw it. You know, at this point, I'm just, you know, using my own judgment and connecting the lines. But once all of this gets put together, I come in and draw the outline. Create the drop shadow. And then I can look around this object and say, okay, here's a sharp point, and draw a line that way. Here's a sharp point, I can draw a line that way. Here's another one. And then maybe I can add one here. The next step would be to create the hatch line. So I give myself a horizon and a floor. And a background. Really what I'm trying to show here is that it's just a set of rules, you know, and those rules can be reproduced physically or digitally. And in a way, you know, I didn't know these rules before I embarked on creating this algorithm. So through the process of using generative art, I'm sort of informing myself of a traditional process, a way to effectively create a consistent style of drawing. So at this point, then I would come in and put in all my points. I do that by hand. But you kind of get the idea, is that something to consider is how does generative art, or how do computer algorithms improve, or how do they inform our traditional practices too, you know? So there you go, a really random rock on paper. Okay, so if there's any questions, I encourage you to type them into the chat box. But other than that, I want to maybe look at some of the actual functions inside of my code that have been instrumental to me creating a project like this, as well as other projects. The first function I want to talk about is one that I call a growing line. And it sort of represents that very first line in the really random rock algorithm. So here in this example, this is basically just that algorithm, or I wouldn't even call it an algorithm, just that function in action. So what this function does is it takes a point, and then it draws another point, and then it calculates the direction of the previous point to this point, and then it adds another point, you know, and then another one, another one. So it's like basically it's a line that just grows from itself. And the way that this function works is down here. Let me blow this up a little so it's easier to see. So I have two functions that sort of work together. The first one I call buildNode. So this gives me a starting point. Basically, I tell this buildNode function, start a line at this X position and at this Y position. And this line is going to travel in this direction. So by 180, that means straight upwards. Imagine 360 degrees around a circle with 0 being down and 180 being north. And then the length is like, what's the span between points? So what I do here is I I just put it into an array. And by the way, if you see this PV function in my sketch, you can, in your mind, you can just replace this with create vector. I just shortened it to, in my practice, I shortened it to point vector because it's easier to type and it saves space. So this is just a create vector XY. And so I create this point, and then I use this function here called pointFrom. And this is another function that I wrote that has been pretty important for me. So here's how it works. I give this pointFrom function, I give it a point, I give it a direction, and I give it a distance. So I'm saying from this point, add another point X amount of distance away from it in this given direction. And to do this, I'm feeding the point data, so the X value, into a sine and cosine function. So I'm saying point X minus the the sine of the radians of the direction. So take the direction value, turn it into radians, put it into a sine function, multiply by a distance, and do the same thing with the Y on a cosine. And this gives me a point, like let's say I have point A. I want a point that's like 10 units to the east. Well, then I would say put point A in here. The direction will be east and the distance will be 10 units. But of course, I wouldn't say east. I would say 270 degrees. Right? So this is like what's happening in this growLine function. And it just keeps adding a new point to the front of that array. There's a second function that has been incredibly useful for me too, and used all over the Really Random Rock project. And this one's called pointDir. I call it pointDir, but just point direction. And what it does is it calculates, given 2 points, it calculates the angle that they're pointing in. And it's doing this using the addNode function, which if you haven't gotten into addNode, it is super, super useful. I have it pulled up here. So the addNode function, what it's doing is it's calculating the angle of a point given a horizontal line at position 0. So like, let's say that this is the 0 y-axis, and this is the 0 x-axis, and this is the point 0, 0. Well, if this point is 2 on the x and -2 on the y, then this theta value here that the math addNode function returns is actually the angle from that ground plane to that point. So what that means is that in order for me to calculate the direction that this line is pointing in order to add a new point to it, I have to know the angle that the previous point is pointing in. There's a lot of points in that sentence. So looking at that, looking at the code here, what I'm doing is I'm feeding point 1 and point 2 into the math addNode function, and I'm subtracting one from the other to put that point at the position 0, 0 on the grid. Because it functions, the addNode function operates on position 0, 0 of the grid, right? So I have to subtract one point from the other to find that position, and then calculate point 2's angle from point 1. So this function right here, point direction and these two functions, point direction and pointFrom, work in tandem. And basically, all of my projects, at least all my recent projects, and what those two functions have done is they've enabled me to create work that is beginning to take on a somewhat of a representational quality. And that's something that I'm all about. I kind of had this goal at the beginning of 2022. I said to myself, you know what? I'm going to do everything I can to create a work that is figurative, like it has some sort of human element that that the viewer can sort of relate to or can respond to, because we are humans, and we look at all this abstract work online and it's lovely, but at the same time, there's like you gotta like my goal is to break through that abstract geometric wall. So these two functions that I've been sort of explaining, they have sort of helped me break through to that. So what's happening here is those two functions are just basically operating together. Now I can alter the way that these lines operate. Here, for example, is the code that's doing it. So here's where I create the first node point. And then down here is where I'm adding nodes. Every single loop of the draw loop, it adds another point to the end of that array, and another one, and another one. And here I can sort of manipulate how much wiggle the line's going to have. So for example, if I set this to a lower number and I set these two to 0, then the line might be a little straighter, less wiggle. If I so what I have here in these two options is how much to unbalance the line by. So if I set this to like 20, then it'll lean more to the left than to the right. So I can sort of bias the line to be more curving or more straight. I can also incorporate a whole bunch of randomness into it by increasing the random value here. So very jagged. Here on this last parameter is how much spacing between each node. I had it set to 3, but I can set it to 20. And you can see that it's much more spacey. So like kind of operating on this level of manipulating lines, point and line data has like opened up the world to me in terms of making new kinds of work that that I just never thought I would be able to do. So those two functions are incredibly useful. Let's look at maybe some of the other things going on back here. So another approach to these lines that I'm talking about is taking that same formula that I have here, the buildNode and the addNode, but combining those together into one formula here. I call this one just growLine. And this kind of will show you that how it's operating even more. So for this function, I give it a start position, and then I give it an angle which I want it to travel, like the beginning angle. And then I give it a target angle. And this target angle is like, where do you want to travel to? Like, do you want to just travel randomly in any which way, or do you want to actually like target a specific direction? And then just some more things here to manipulate the like how wavy it is and whatnot. So with this this function here, I'll show it to you in action. So I'm just going to fill this with 10 lines. So here is that function happening with 10 lines. So I told this function, create a line that starts at this position, but is trying to reach the position that's just directly north. It's trying to reach an angle in itself that points vertically. So you can see that just by having 10 lines, they're all going to do something slightly different. And I'm putting a little bit of randomness in here. I can control these lines to an extent, and like just basically I'm showing you this because this is kind of what's happening behind the scenes with really random rock. The way these lines are actually drawn, sometimes they're random, but other times they can have more intent behind them. So let me see here. So maybe now's a good time to just pause for a second and see if there's any questions out there that might be popping up. You run this, and if not, then I have some more code stuff I can sort of talk about.
I have a question. I could save it to the end too, but I'm wondering with the orientation of the rock when it spins, exactly how it chooses the best orientation. I know you touched upon that, but
Oh yeah, totally. No, that's a good question. So basically what's happening is, here, let me actually run over to it in the code here. So I'm going to do this right there. And then I'm going to uncomment all of this stuff here. So, okay, so let's look at this in action. All right, so it's drawing its basic shape. It's creating those expansion lines. I think it's going to make 6 of them before it starts rotating. Now, once it rotates, look down below, and you're going to see this horizontal line. This horizontal line is basically, and it goes out of the frame a little bit. That's fine. It's still functioning even if it's outside of the frame. But here we go. You can see that this line is intersecting the bottom portion of that rock. So it's kind of like saying, how many points of intersection do I have down here? If there's only 2 points, then it's probably going to be like a sharp element like this. So I don't want the rock to be rotated to where this is pointing down. I want the rock to be rotated where a line that has multiple points intersecting it. So for example, right here, it's kind of hard to tell, but it looks like if I were to draw my mouse across this line, there's going to be an intersection point there. There's going to be one right there. Maybe there's another one there. Maybe there's another one there. Maybe there's another one there. So that has a high number of intersection points. So that means put that side down. Rotate the rock to where that part is down. So in that process of rotating the rock, I'm basically scanning it for points of intersection, and I'm collecting all that info in an array. And then I'm taking this array that's just all point data, or not point data, I'm sorry. It's just rotation angle and quantity of intersections. And I just sort this array from the highest number to the lowest number. And I take the highest, once it's sorted, it's ordered from the highest number of intersections. I take the rotation angle from that value, and then I rotate the rock by that much. So down here in the code, we can probably find that if I just search for sorts. Here we go. So here's the function that actually does this. So step final rotate rock. So I make up words along the way. I don't know if anybody else does this, but I created an array called rotating rock catalog. It's just a catalog of all the rotations and all of the intersection counts. So I'm taking this rock and I'm rotating it right here. Where is it? Line intersects curve. Let's see, where's the rotation happening? Right. Okay, well, let me find that in a second. Basically, here is where the data gets pushed into the array. So the rotation amount, and then however many points of intersection. So here's a function called line intersects curve, and it tells me if I give it a line, so this is my point x, my point 1 of the line, and my point 2 of the line, and I give it a shape, it'll tell me how many points that line intersects that shape by. So I collect these points. I collect these points, I put them into this array, and I combine it with the rotation angle. So I'm rotating the rock 3 degrees at each turn. And then here is where the rotation is happening. So I keep my rock outline in a variable called v. I just got used to using that value for my like outlines and stuff. So I use it in all my projects. So v contains the outline, and then I put the outline into this rotate shape function right here. And with this function, what this does is it takes a set of points and it takes a handle, and then it takes a rotation amount. So this kind of stuff is maybe it's not so commonly used, but when you're dealing with plotting, you really have to capture all the point data. And so once you have all that point data in arrays, then you can start to do really interesting things with that point data. So for example, this rotate shape function, if I go over to my, I have basically a library of functions I've written that are just useful. And whenever I create a new project, I pick from all these functions. So here's my rotate shape function. It takes the outline, it takes what I call an anchor point. So where am I going to grab this rock and then rotate it by? I'm grabbing it, in this case, I'm grabbing it by the very middle of the rock and I'm rotating it around that way. And then I'm taking an angle. And I'm using this function here called rotate point, which takes a single point, moves it over to the X and Y position of the canvas. So I'm subtracting the anchor point from the point data. That puts it over in the X and Y 0 range. And then I'm rotating around 0. And then I'm adding it back to bring it back down to its position where it was originally. So for that outline, I go around that outline of that shape. I take each point, move it to 0, rotate it, move it back, go to the next point, move it to 0, rotate it, move it back, go to the next point, move it to 0, rotate it, move it back. You get the idea. So not only can you do rotations this way, but you can also do translations, scaling. One thing I do a lot of is both of those things. So I translate objects, move them around the canvas. But I'm not doing this by using push and pop, which I think are the two functions in P5. Like you can basically, you do like a push and then you translate the whole entire canvas to a position and rotate it and then you pop it back. Instead of doing that, what I'm doing is I'm just taking the points themselves, moving them over to 0, manipulating them, and then moving them back to their original positions. So it's a bit of a technical thing, but it's easy to do. But once you get the hang of it, it's just a matter of using the P5's create vectors. It has a whole bunch of built-in methods like a subtract method, an add method, a multiply method. So for scaling points, what I'm doing is I'm moving them over near the 0 of the X of the grid, and then I'm multiplying that point by a specific amount and then moving it back to where it was before. For a translation, I'm moving things relative to an anchor point. So, really what I have here is just basically just translation functions. I'm sure they're not, they're more common than I think. But I've written a whole bunch here and I collect them in these files. I sort of build these libraries for myself over time. Like for example, this one has all kinds of things like stitching the ends of an open shape. I have things like, is a point inside of a shape? Yes or no? There's all kinds of things. Getting bounding boxes. So like there's one that's actually used in the really random rock. Let me show you that one real quick. So the bounding box is basically that box that you're going to see around the rock is basically a box that fits the rock in its entirety. And it's just right up to the edges of the rock. I can pause the script, so I'm going to pause it as soon as I see it. Let's see here. Let's do one more. There we go. So here is the bounding box of this this rock. So what this bounding box is doing is it's traveling around I'm basically going point by point and saying, find the lowest point, which is right here, and then find the highest point on the x-axis, and it's right here. And then do the same thing for the y. So the y is right here, and then the lowest point on the y is right there. So if I have those 4 points, I can basically create a box that fits that rock exactly. Although in this case, it's not fitting it exactly because I haven't updated the bounding box. So you're seeing, I think, the bounding box of the previous frame in this view, but the next frame would have the box right up to the edges. And that's what's called a bounding box. And so in my code, I use these all the time. I mean, I get the bounding boxes of shapes, and then from that bounding box, I can find the very center of that shape. I can find a position at the bottom of the shape. And here's my get bounding box array function. So I put the shape array in there, and I have, there might be more efficient ways to do all this stuff, by the way. I'm self-taught. I'm not a computer scientist, so I just kind of do things somewhat naive and brute force all the time. So, but in this case, I have a whole bunch of high values and a whole bunch of low values, and I check each point. Is the new point lower than this one or higher than that one? Right. So I'm basically, if I go around the entire rock doing that, you're going to end up with the lowest point on the X, the highest point on the X, the lowest point on the Y, the highest point on the Y. So the min X, min Y, max X, max Y. And then from those values, I can start calculating, well, how wide is the box? How high is the box? What's the very midpoint of that box? And I put all this stuff into just an object, and I return that object. And I use that object to scale boxes, to scale the shapes with, to move things around. There's all kinds of uses for this. So yeah, that was a good question that brings up a whole bunch of related things.
I had another question in terms of when you were going through the test outputs from some of your early ideas. You said, I mean, there was a lot of cool outputs that I didn't expect to see today. But you said that some didn't translate to plotting. And so I was wondering if creating with that parameter in mind, did you find that constraining? Was it a fun challenge? Or maybe it was a combination of both?
I think plotting, what it did, at least working for Plottable, making a project for Plottables, what it did to me is it challenged me in so many different ways that I never even knew existed. I mean, before that, I was making just work in the canvas that is, just using squares, circles, colors, lines, and whatnot. But the constraints of plotting mean that you have to be extremely mindful of every single point, every single line that you create. You have to know where those points are that creates that line. So creating the project like this for Plottables was like, I mean, it was an eye-opener for me. It introduced me to thinking about lines and shapes in different ways. It, of course, there's constraints, and I don't mind the constraints because sometimes constraints can sort of help you focus on very specific things. And in this case, I focused on points and lines. And so I feel like plotting and making work for plotting like opened up a whole new area of code, at least of generative art for me. I'm sort of glued to it now. And the best part about it is that through this process of making work for plotting, it introduced me to like making SVGs, and SVG data is infinitely scalable. And I already have all the point data in arrays. So now I can just easily convert all that into an SVG, and then I can, theoretically scale an output up to the size of a skyscraper and have it in perfect resolution. Like that's a really, really awesome concept. And I think that's like, that's sort of where it's all at least for me. Being able to scale things up like that. This new project I'm working on for Bright Moments has SVG output. The Really Random Rock, that's an SVG output. Another project I have going on that's a secret surprise project is a SVG output. So like I couldn't have done that without Plottables and without the constraints that plotting kind of made me mindful of. So I think that's a challenge we should all take as artists. And and also for me, it's helping me break through that wall of what do you call it? Just geometric abstraction, which I very much am a big proponent of. But I feel like geometric abstraction is readily accessible directly out of the box with coding, especially these coding platforms that we're using. For example, P5, puts geometric abstraction right in your hands. And so it's actually been a really hard challenge to break out of that, to at least go beyond it to some extent. And one example of that is just making figurative things or representational things like the rock, but other examples might come in different ways. So I'm a big proponent of breaking free from the constraints of geometric abstraction and exploring the sort of like maybe it's not as commonly explored area of representation and figuration, which I hope to achieve by the end of this year, is at least have something that resembles human qualities. I'm kind of getting to this weird place with it, but so yeah, that's sort of a little bit about me, about my how I got to this point. I would say Plottables and plotting sort of pushed me in this direction. So my hope is really that at least my work will inspire people to like dig deeper into some of these things, to keep pushing like the envelope with generative art. And like, for example, like shaders are a huge thing, and that's something I haven't gotten into yet, but I hope to at some point. And I know that it is a whole nother ball game, right? So like, just like choosing like what you want to like specialize in. It's a real hard decision. Like, I'm going all in on points and lines right now, and I want to really explore things like shaders and things like that, but I just don't, I'm not done with this yet, and so like, what will happen to me like in 3 to 5 years from now? Am I going to be like a very niche segment of generative art where it's like just point and line based sort of things? Like I'm really unclear about that, but like I imagine that that's what kind of happens. That there's so much that you can explore that you're going to have to specialize in a particular area as an artist and really focus in on expressing through that style. So I a year ago from now, I didn't know half of what I know today. In 1 year, I can learn so much from reading, from watching YouTube videos, from looking at other artists. A year from now, like who knows where things will be. So it's a really interesting, just coding in general has been really interesting to me and super eye-opening. And I hope to keep exploring all this stuff to a very deep level.
I love that answer. And so we're coming up on 1 hour, but I wanted to ask this question too, which is for current collectors, new collectors, maybe future collectors, if they wanted to go about getting their really random rock plotted, do you have any advice?
Absolutely. So there's a couple of ways to do it. One is you could get a plotter and plot it yourself. That's always an option. Alternatively, I have a plotter of my own and I plot rocks. There's a website floating around out there. Let me see if I can, after this video, I'll find it and I'll post it. I guess I'll post it in, I'll post it in a couple of different places to make sure it gets seen. So maybe on Twitter and in the Plottables Discord and in the ArtBlocks Discord too.
And we can share it in the video description as well.
Oh, perfect. So in that case, you have to own the rock that you want plotted. It's a Web3 sort of website. You connect your wallet. If you have the rock in there, then you can actually make the purchase, and I will plot it, ship it out to you, and then you can have the rock, frame it, etc. I've probably made about 30 of them so far, and it's just such an awesome, rewarding process, like watching the things plot and then knowing that a computer made it but at the same time I made it, but then this robot made it.
Yeah.
It's like, what's going, it's just super rewarding. So that's
No, that's
how,
awesome.
yeah.
This is such a great presentation. It really shows your background as a teacher. It comes through. I think your patience with everyone listening. I mean, I know you're literally not like talking to a room full of people, but you can still feel that energy. It's really, really incredible.
Thank you.
And I want to thank everyone who joined to watch live today and those who will be watching in the future. And a very, very, very special thanks to Dan for speaking on his project, Really Random Rock. Till next time, be great and happy minting.
Thank you. Bye.